Welcome to the School of Brink. Professor Brinkman here to teach you another mathematical concept. Okay, so today we are learning about logarithmic functions. As you see here, this is a logarithmic function. The first thing we need to know is that logarithmic functions are inverses of exponential functions. And exponential functions, we know the equation for an exponential function is y is equal to 10, or pretty much any other base, to the x power. And so if it's an inverse, then we will obviously change the x and the y, just switch them around. It's very easy. So if we have y is equal to 10x, then it becomes x is equal to 10 to the y power. So if the x and y change, then the graphs will obviously change too. So if we have the exponential function right here with the horizontal asymptote going up, an inverse just goes across the x is equal to y linear equation. So we have this, as you can see, it's a reflection. So if you reflect the exponential function across the x is equal to y, you now have this logarithmic graph. Lastly, the horizontal asymptote. If we have a horizontal and we switch opposite, it will now become vertical. We can also check ourselves with this by finding points on the graph. So if we have an exponential function, we have 0, 1 as the x-intercept. Right here, we have 0, 1. Then the inverse of that for the logarithmic should be 1, 0. And it is, right here. And then we can also try it again with 110. If it's 110, it should obviously then be 10 to 1. It's very simple. You just switch the x and the y, both on the equation over here, the graphs, and the points. Go to 10x up 1. Finally, we can check ourselves with the domain and range. As we know, the domain is from the smallest x to the largest x. So if we're working on the exponential right now, which is in green, we know that the domain goes on forever. It will continue left as far as we want. It goes from negative infinity, and so infinity can never have a distinct point, so it's a parenthesis. We're going to go from negative infinity, and this line will continue to keep going that way. It goes up, but it goes at a rate. So it's at a slant that just keeps on getting steeper. So therefore, we will then have infinity to infinity, or all real numbers. But then, if we have the range for the exponential, we go from 0. Because this is the asymptote. Remember, the asymptote means it never touches the line. So the asymptote, it gets as close as it can to it, but just keeps getting smaller and smaller and smaller, closer and closer and closer. So we start small and go up as high as we can. So therefore, that's 0 because it never touches the that x-axis, and goes on to positive infinity. If we look at the logarithmic functions, the domain and range should be opposite. So therefore, we should have the x, or the domain, should be from 0 to infinity, and the y should be from negative infinity to infinity. We can check that. The graph keeps going down and down and down, and then it goes up and continues at a slant and just gets steeper going sideways. So that is correct for the x. It starts at the 0, and now the horizontal asymptote, it goes to the right. And the y then goes from negative infinity as far down as it can, and all the way back up. So this, we can show, it is the inverse. The domain and range of the inverses on the graph is reflected across the x is equal to y line, and the equations for it are also switched. The x and the y's are switched. And lastly, we got the points. So the basic thing we need to remember is that the x and y are switched in logarithmic and exponential. They are frequencies. So on to the next slide. The next thing we need to learn is the vocabulary. So here we have the regular standard exponential form and the regular logarithmic form. The first vocabulary we need to learn is we have the exponents. Let's change to a different color so you can actually see this. You got the exponents right here, the y's. This is the exponent. So if we have the exponents right here, as you can see from the exponential, it comes over and then the logarithmic equation is now equal to the exponent. The next thing is the 2's. The 2's are called the bases. The base because it's on the bottom, it's like what you're sturdy on. So we got base 2 is the base in this standard form. And lastly, we have the argument, which is, we can remember this by this is what justifies the answer. Over here justifies the answer, and so whenever we're actually solving the problem, it will then justify the answer too. Now we got the argument. So, we have this equation. How you would say it then, you would say log base 2, because we remember we get the base right here, base 2 of x, like base 2 of x is, or the equal sign, y. So now I guess we'll go on to the next slide.